In reinforcement learning, an artificial intelligence learns from the interaction with its surrounding. It is comparable like how we as humans or animals, for example, learn. For example, let's say you're a dog owner and you're just cooking something. And your dog smells what comes out of the hot pot on the stove and he likes it. If he's trying to reach it, he will hurt himself. And this is a bad experience for him, and out of that he learns not to do it again. On the other hand, when you want to teach him to sit down, you give him a treat if he does so when he's commanded. And this is a reward for him, and out of that he learns to do it again. This concept we now use not to learn to sit down, but to learn how to supply a machine, for example in the household, like a washing machine with power, for example supplied by a solar system on your rooftop. For that we have an inverter here in the lab, which can supply the machine with the required voltage. Therefore, we want to train an artificial intelligent program with a reinforcement learning idea, which is implemented on software on this very fast computer here. And it receives voltage and current measurements from the system and can interact with it by closing or opening the power switches. Thereby the goal is to ensure that the machine is supplied with proper alternating current and voltages. If the switch thereby is opened too briefly or not at all, the power wouldn't be sufficient to turn on the machine. On the other hand, if the switch is closed for too long, the current may heat up the system, burn the switches or the power line, and this could cause damage. And since we are dealing in the following with a system which corresponds to an equivalent power of 17 household PV systems, we really want to avoid this situation. Not only to protect our system here, which was quite expensive, but also the people nearby. For this purpose, we have extended our AI control concept by a safety component, which we've called the safeguard, which checks whether the switching interaction planned could lead to a damage, and it prevents that. That's comparable, for example, to a dog owner, which prevents the dog from touching the hot pot. And of course, the dog only learns out of that if it gets an appropriate feedback from its owner that it shouldn't try to touch the pot again. And the same applies for the AI and the safeguard. So if we have to intervene by the safeguard, a negative feedback is given to the AI to learn to not to do this again. On the other hand, if the interaction leads to supply the load with a desired voltage, we give a positive feedback. This mentioned interactions happening very fast with this very fast computer, and a lot of experience is gained to be used to train the artificial intelligence. The actual training is not happening on this fast computer, but on an external edge computer where the experience are sent to. After the AI has been improved using this real-world measurement data, the improved AI parameters are sent back to the fast computer to be used in the interactive control process. And with this concept, the AI can learn to supply the load within 7 minutes without prior knowledge or any prior training, which on the other hand would require an expert, and that would take a long time to design an appropriate program with comparable quality. And we could even show that the AI in some situations even can fulfill the task better in some cases.